Having brainstormed a whole list of possible causes of my problem and organized them using a fishbone diagram, I can now begin to chase down each possible cause. Any follow-up, however, must be based on data. For example, I have hypothesized that inadequate employee training is related to long wait times. Sounds reasonable enough, but let me collect some data to see whether that relationship is in fact true. If it is true, what is the strength of the relationship? Without that information, it is difficult to decide how much time, money, and effort I should invest into employee training. So I dig deeper into the complaints about long wait time. For the past 2 weeks, I note down information regarding the number of complaints in each shift. Further, I look into my HR records to note down the extent of training that the employees in each of those shift crews had received. Here is the data I collected. Unfortunately, by just looking at these numbers, I am unable to see if there is any pattern here. Is the average training level of the crew related to complaints? If I had X-ray vision, I might be able to figure it out, but right now the relationship eludes me. I decide to plot these numbers on a scatter diagram. Note that I'm plotting the cause, or the independent variable, on the x-axis, and the effect, or the dependent variable, on the y-axis. X is causing Y, or inadequate training is causing complaints. Looking at the scatter diagram, there does seem to be an inverse relationship between training and complaints. The average training that employees have received, plotted on the x-axis, varies from 40 to 80 hours. The complaints seem to vary in an inverse manner from 25 to 0. As we can see in this example, the scatter diagram is a useful tool to visually recognize a relationship between two variables that may not be visible from looking at the same data in a table format. Drawing a trend line through the scattered points seems to highlight the relationship somewhat. However, the points seem to be all over the place relative to the trend line. Just how much of a relationship is there between the two variables? What is its strength? To what extent are the complaints attributable to lack of training versus other factors? Without assessing that strength, it is hard to justify any substantial investment in additional training. This trend line plotted on the scatter diagram is nothing but the regression line of best fit. The extent to which the points are scattered relative to the trend line, or conversely, the strength of the relationship, can be assessed by a regression analysis. Here are the results of the regression analysis. Let us interpret the results. Here we have only two variables in the regression, the effect, that is complaints, and a single cause, that is training. The effect is the y variable, which is dependent on or regressed on the cause, which is the x variable. Since this is not a multiple regression with multiple causes, the multiple R of 0.67 is the same as the correlation between training and complaints. Also, we can see from the scatter diagram that the correlation is negative, so the correlation coefficient really is minus 0.67. So there is a moderate inverse relationship between training and complaints. A more meaningful number than the correlation coefficient R is the R squared, or the coefficient of determination. The R squared value of 0.45 indicates that 45% of the variability in complaints is explained by the variability in training. The remaining 55% is due to other factors not included in our analysis. No wonder the scatter points are spread out widely about the trend line. Essentially, if I increase the training of my employees, there is a 45% chance that it will pay off in terms of reduced complaints. I need to decide whether these odds are good enough for me to go ahead with the training. As you can see here, there is no easy answer to that question. Obviously, as with anything else in life, there is no 100% guarantee. I will have to take into consideration the cost of the training on the one hand versus the chances of avoiding customer complaints on the other. Let us say I am happy with the 45% odds and am willing to invest some money into training. But is the 45% really a number I can trust? After all, I only took a sample of 28 observations over a 2-week period. Maybe there really is no relationship between training and complaints, but just by fluke, this sample happened to turn out this way. The F test gives me information to answer this concern. The significance of F is 9.38 times 10 to the power minus 5, or 0.0000938. What that implies is that if there were truly no relationship, the odds of my getting a sample like this by fluke is about 9 in 100,000. Given such small odds, I am pretty confident that the relationship is not zero. Note here that I still don't know for sure how strong the relationship is, but I am confident it is not zero, and my best guess is 45%. The intercept and slope of the regression line of best fit give me some more information about the relationship. The regression line allows me to estimate the number of complaints I can expect given a certain training level. This estimate is given by the equation complaints equals 30.55 minus 0.328 times training. The intercept of the regression line estimates that if I provided zero training, I can expect 30.55 complaints. I really don't want to put much stock in that number, however. That's like using data points ranging between 40 to 80 hours of training and trying to extrapolate down to training equals 0 hours. The slope of the regression line is a more meaningful number. It tells me that for every additional hour of training that I provide my employees, I can expect complaints to reduce by 0.328, or about a third of a complaint. Once again, is this a number I can trust, or just a fluke? The p-value from the regression output gives me the significance of the slope as 9.38 times 10 to the power minus 5. Just as with the significance of f, if there were truly no relationship between training and complaints, the odds of my getting a sample like this by fluke is about 9 in 100,000. Therefore, I am pretty confident that the relationship is not zero. Once again, I still don't know the exact relationship between training and complaints, but I'm confident it is not zero, and my best guess is minus 0.328. Although I don't know for sure what the value of the relationship is, the 95% confidence interval of minus 0.474 to minus 0.182 gives me a range surrounding my best guess. Based on this information, I now have to decide whether I should invest more money into employee training or not. The remainder of this presentation shows how to create a scatter diagram and conduct regression analysis using Excel.